Does that sound good?
Yeah, if I'm getting up in time, tell me to speak.
It's my great pleasure to introduce our speaker for the distinguished alumnus of physics, Mr. Bob Woodruff, for Ernest Nichols lecture. But before I do so, I will give you a little bit of background to this lecture. Ernest Fox Nichols graduated from Kansas State University, used to be called Kansas Agricultural College then, in 1888.
Oh.
Then he did a lot of research on infrared spectroscopy and became very famous doing so. He became the president of Dartmouth and MIT. And more to his fame, in 1893, he published a paper on infrared spectroscopy of certain substances, and that came out on volume 1, page 1 of Physical Review.
Oh, wow.
And you can publish any other brilliant paper after that.
Yeah.
But the 1-1 coordinate is taken. So that's the background to Ernest Fox Nichols. When Dean Zollman was the department head, he decided to use Ernest Fox Nichols as a lecturer for distinguished physics alumni. And Bob Woodruff is going to present this year's lecture. Bob has graduated from Kansas State in 19.
Yeah.
You're not recording, are you? Just take silent pictures.
1894, yeah.
Yeah. 19. Well, okay. All dates are equal before we have one of those, right? 1964.
Yes.
I got that one right, fine. Okay. And then he got his master's in 1965. Got that one right too. And then he became a member of the technical staff in Lockheed Martin and also an associate with University of Colorado. Did a lot of good work on optics of space telescopes. And you're going to talk about that. But before he does that, I would like to recognize one other person in the audience. And that's Mr. Kane Ohm. Would you please stand up, Mr. Ohm? Mr. Ohm is the person, the high school teacher, who has inspired Bob to become a physicist. And we need more high school teachers like that, right?
Amen.
So, and what did inspire him? He will tell you a lot more, but I will just add one thing. Bob was thinking what to study, what to specialize in, and then in high school one day, Mr. Ohm had a Van de Graaff. And he has a cat hair that you wear, and touch this Van de Graaff, and all his hair stands up. And Mr. Woodruff says, this is it.
Yeah.
Okay.
Yeah.
I will not take further of your time, and here,
Okay.
Mr. Bob
Yeah.
Woodruff.
Thank you very much. Thank you. Yeah. So I tried to get cute with the title because I had fun with physics. This is, I was a townie. I was born, raised here in Manhattan, and attended Manhattan High School, attended all the public schools in Manhattan, went to Woodrow Wilson, went to Theodore Roosevelt, and graduated in 1961 from Manhattan High School. I studied here. I got my bachelor's here in 64. Graduate school, I got a master's in physics at Illinois in 65. my first job was at Boeing Wichita. I wanted to be close to the family, and very disappointing. I was not inspired at all. My second job, and this is where I did the instrument work that I did at Ball Brothers Research in Boulder. I loved it. I got there, we worked hand in hand with each other, we're co-workers, we're friends, we concentrated on what we were doing, learned new things, and I loved it. Then I decided to try in '79. I thought I could move to a warmer place and do the same sort of work. Well, I tried that for 2 years. That did not work, so I went back to Ball. And almost all the instrument work I'm going to show you I was done when I was at Ball. So here, I found this. Can you just find me there? So that was 4th grade, 52, I guess. And I had big ears. Anyway, there I am. I showed that to my aunt. I have one aunt still alive, age 94, and she said, yeah, that's Bobby, that's Bobby. So she lives out in Wamego on a farm. Okay, what do I say here? Okay, I did not intend to even attend college until I took physics as a junior in high school. I took it because it was required. And you know, I was going to work at Sears or the post office. That's what my family did. You know. And then so a 16-year-old student, I took it, and I just got turned on by physics. And I don't know if you all know what this is. I got this when I was 16. We'll have a quiz later. It's based on logarithms, by the way. Study math, take math. So anyway, so then I started taking classes up here. That summer I took classes in algebra and trig. They didn't have that at high school. And then my fall and spring semesters, I took classes in calculus up here. And then I graduated, and then so I got to college, and college just opened my world. I mean, we were agriculturally focused, and I lived in town, and education was not part of our tradition in the family. And I got up here, and I saw art and science and you name it. I mean, and I loved it. History, I just loved it. So anyway, the world of knowledge and possibilities, that's what I found here. And K-State gave me a good education doing that. I'm still very I'm into idealism and wonder. I just have interest in numerous things, and I really have strong feelings towards that. The mind is a wonderful thing to use, and the world is here. It's our oyster. And I think this is probably common among scientists and others too. There's what's the next question? What's around the corner? And I'm going to show you some things, and I feel I've made a contribution, but I'm not yet. I'm not done yet. So hopefully. Okay, I won't spend much time on this. Very briefly. Okay, I worked at Ball Aerospace. I left a few times, came back, but from '67 to 2000, more than 30 years. I get a pension from them. I get a pension from Lockheed Martin also. I worked there for 8 years. I worked on numerous space missions. Skylab on our first space station, Skylab back in '71 or '2, and I worked on 2 of the instruments that stared at the sun. One took chronographic pictures of the chronograph of the corona on the sun, and another that did UV spectroscopy. Atmosphere Explorer was looking through the atmosphere, scanning through the atmosphere down into the far UV, using the sun as a light bulb to study the composition of the atmosphere. Soyuz, there was a telescope on that they made the first soft X-ray pictures of stars. first ever, done for Berkeley. And CZCS studied chlorophyll in the ocean and imager. And okay, a lot on Hubble. I'm going to talk about that later. And James Webb at the start of that, that's a telescope that's coming down the pike, spending all our money, but it's going to be launched in 2018 maybe. Planet finding, finding planets around other in other stars. Worked on the start of those, and also I designed the Kepler, which is doing a census of those things. I'll touch on that briefly. And beyond Einstein, well, that's part of dark energy, and I've worked on studies for those instruments, and that's a major thrust in NASA right now. So anyway, wide spectral range, UV out to the far infrared. I did the optical design of 5 of the 12 instruments on Hubble. Hubble, they go up and they change instruments. Now they had the last servicing mission, that's over, but anyway. So I did that, the optical design, on the science teams and the like. 4 of the 5 currently on Hubble. Expertise in optical physics, optical design, optical system engineering. I basically learned it using what I learned at K-State and in Illinois. I learned it by on the job and working with experts, more than 20 flight instruments. I have to update that. It's more than 20 flight instruments. Basically, something I've designed has been flying in space, I think, continuously for 40 years. And there'll be another decade or so, or more. Okay. I've talked about dark energy and solar planets. So anyway, today I'm going to talk briefly about 2 things. Fixing Hubble Space Telescope, the spherical aberration, and then briefly on how I conceived the design for Kepler, as that was a very difficult design. Okay, you all know about Hubble. 2.4 meter aperture, 10 feet, okay. 58 meter focal length, works from the UV, vacuum UV, up to the near infrared. That's what these wavelengths are. The visible is about 500 or so. It weighs a lot, has science instruments, 5 science instruments, 4 axial and 1 radial. By that, these right here are axial instruments. They go together like butter cubes. They are about 2 meters tall by a meter. So they're big, and Hubble is big. The radial instruments go in from the side, and they're the size of a baby grand piano. There are fine guidance sensors that were going to be used for some science, but because the aberration was not able to use it. It's in low Earth orbit. It was visitable. It was able to be visited by astronauts on shuttle. And they would install new instruments as technology went along, and a new question would pop up. One instrument would generate another question, and the next instrument would use updated technology and try to address those questions. So that's Hubble, and this is just quick pictures of it. There it is in orbit. That's a sunshade. It's a door that flops down there. So the sun's on this side. But if it loses attitude, that door shuts. These are solar panels that gives the power. Here is the telescope itself. The telescope is in this region right here. That's the telescope on the ground, 2.4 meter, and those are people. And here an astronaut is installing one of the axial instruments. And there's another picture of him doing that. Here's the mirror. Primary mirror, 2.4 meters. Taken before his launch, obviously. A very, very perfectly figured mirror of the wrong conic constant, of the wrong eccentricity. It's a hyperbola, which is a conic, and it was supposed to be